Yeah, very good morning to all of you again. Let us discuss about binary search tree. And if you see what happens in the binary search tree is a binary tree, but this search tree it's a tree designed to make an effective search in the tree. So using tree we can search very fast. So but there is a very specific properties for this tree. Special properties is that the value at the node will be greater than the value at the left. You understand that you have it's a binary tree. It has a left child and a right child, but this is a numerical tree. So the left child will be always lower than the root, and the right child is always greater than the node. So take a look at this. It's actually, if you look at this example, now this example we basically have a root is 7, and then we have a left is 5, which is lower than 7, and the right is 9, which is greater than 7. Again, take a look at 5. You have the right, which is greater than 5, and the left is lower than 5. So this is a binary search tree. So if this search tree, if we go for in order traversal, in order means, you understand, in order means left, node and right. So left, node, right. So if you search this binaries, if you traverse this binary search tree using in order traversal, how you are going to write it? You say 3, 5, 6, 7, 9. That means numbers are automatically sorted. So any binary search tree, if you do in order traversal, it will be automatically sorted. But take a look at this one. I said that this is not a binary search tree. Why? Because 10, the left is actually higher than 10, right is also higher than 10, but left child cannot be greater than 10, and that's the reason it violates the properties of binary search tree. So you cannot call it a binary search tree. Now take a look at, I want to discuss first the operation on binary search tree. Now what happens in the operation on binary search tree, if I consider this is a search tree already we have. What do we have here? We have 12, then 9 on the left, 15 on the right, and then we have left 8, and this is a binary search tree we initially have. Now we are going to first insert 18 in this tree. So it comes at the root and then compare the value of the node with the root. It finds that 18 is greater than 12, so go to the right. It comes to 15 and then compare again, is 18 is greater than 15? Yes, so go to the right and it's connected here. Now the next item I'm inserting is 11. You can see here when 11 comes here at the root, it's compare the value whether 11 is greater than 12. No, so go to the left, and then it comes to the 9 and it compares the value whether 11 is greater than 9. 11 is greater than 9, yes, so go to the right and it gets connected. So in insert operation, what we are doing, the node comes to the root and compares its value, compare the value of the node with the value of the root and decide whether go left or go right based on the value. Is that clear? I hope it's very clear to you. If you consider delete operation is very straightforward. For example, if there is a leaf node, a leaf gets automatically deleted. Just you travel and find out and remove the node. And if there is a node in between you want to delete, then you have to swap with the higher value and then take care of the other part of the operations. I talk about one more very important exercise which is very common, and it always we face this. You suppose I give you a set of number in an array, and these numbers you have to convert them into a binary search tree. So it's very challenging job sometimes, that a set of numbers. Why we do this? Because any number we are actually going to arrange in binary search tree so that we can search it very fast. Now this is a set of number given in an array, and what your first task will be to sort this number. So once you sort it, then you may start choose a middle number to form your binary search trees. Let's consider I've chosen actually 10 here, and then I gradually formed a binary search tree from this array. So you see here 10, then comes 4 which is less than 10 is on the left, 11 is greater than 10 is on the right, and then 18 is greater than 11, it gets onto the right, 12 is less than 18, it gets onto the left, and 22 is greater than. So it's actually a quality, it's a correct binary search tree. So my suggestion is that you need to take a look at some of the exercises. Like, we need to talk about why binary search tree is important and binary search tree operations, especially insert and delete operation, and take this as an example exercise for you to convert this array into a binary search tree. But you can understand binary search tree property is the left must be lower than the root and the right must be greater than the root. I hope you take a look at this again. Just to repeat you, just to review again, it's a binary search tree. It's a binary tree, but it has a property: the value of the at the root is always greater than the value at the left, and value at the root is always less than the value at the right. And it's a numerical value. You do not have any duplicate data in this tree. It's always unique, and it's all about actually binary search tree and its operation. I hope you enjoyed it, and we discuss in the Google Classroom. Yeah, take care. Thank you.